All right. Welcome. How do you like our little Duke rock stars here? So there's stickers going around somewhere, so you can get some of these stickers. I think we have 4 different rock stars or something. Anyway, so this talk is about Quarkus, obviously. Who am I? I'm a developer advocate at Red Hat. My name is Kevin Dubois. You can find me on Twitter or Mastodon, and yeah. So I know we've already talked in a few sessions today about traditional Java and the startup time and all that stuff. So I'll do that some more. So we'll talk about traditional Java. So traditional Java is, can I see the little hand? Traditional Java is designed for, let's say, different times. It's not designed for cloud native workloads necessarily. It's designed for running kind of long time. And what's important in traditional Java is throughput at the expense of footprint. So the footprint can be quite large, right? You typically have traditional Java applications running on pretty beefy servers. And they're designed to be long running, and you have dynamic loading and all that stuff with mutable systems. But in the cloud native world, your throughput, you get that mostly through scaling. Your workloads are ephemeral, which means that, like if you think of containers, when you scale up a container, when you start up a new application, those containers are going to start up, and then maybe they're going to get rescheduled on a different node. And so containers kind of come and go. They're not going to be around. And if you change something in a container, that change is not going to last, right? Because that container, whatever you changed inside, that's going to be gone when that container gets removed. So, so in that sense, we have to think of Java in a different way. We need to think about the footprint of it, because we want smaller containers that we can schedule across different servers. If you are familiar with Kubernetes and clusters, there's usually multiple servers on which it schedules containers. So we need to be able to handle that. And so that's where Quarkus started, was kind of invented, I guess, because it's a framework that uses Java, but it's, we call it supersonic because it starts up very fast, subatomic because it's very small, like subatomic, smaller than an atom, and it's still Java. So if we look at Quarkus in terms of startup time and in terms of memory usage, you can see here, this is a test that they did with a relatively small application running on a traditional cloud native stack. It took 136 megs of memory. Running the same application, with Quarkus, you already got pretty good gain in memory, right? And that's running on the JVM, so it's the exact same application running on the JVM. And then, compiled down to a native with GraalVM, you get, of course, even less memory usage. And you can see here, too, Quarkus starts up quite a bit faster than a traditional cloud native stack, which is ideal when we're talking about, cloud native, when we're talking about containers, talking about serverless, where we need to start up really fast so we can react quickly to, changing loads. So startup time is one thing. There's also the warm-up issue. I don't know if issue is the right word, but actually when an application starts up, it takes a while with Java before you get your maximum throughput as well. So here we can see that, like a traditional Java application, this is actually the point, and I think this is like 13 seconds or something, before it's actually able to be working at maximum throughput which, for this particular use case, it needed a certain amount of throughput to be able to handle the load enough. And then you can see here with Quarkus, it goes quite a bit faster. Now, Quarkus isn't just about fast startup time. It's not just about memory, but it is kind of a nice feature of Quarkus. So if we think of containers and Kubernetes nodes, traditional Java applications running on EAP or WebSphere or whatever, running on a Kubernetes node, you can see they take up quite a bit of space. Let's say that in this case, only 4 instances of the application can run, which isn't so ideal, because if one of the pods, one of the containers goes down, that means you lose 25% of your workload, right? If you look at Quarkus, on the JVM, you already have quite a bit more density, which means that if one of these guys goes down or needs to be rescheduled or whatever, you still have, what is it, maybe 70 or 70% or something. That's still up. And we can compare that to Node.js or Go or something, where Go has quite a smaller footprint, and with Quarkus native, we can actually be very comparable with Go, which is nice because that means that we can use our Java skills and not have to change languages and reinvent the wheel, and still get all the benefits in the cloud native world of having fast startup and everything. So how does that work? So a traditional Java application, basically build time is when you do your packaging, and then as it starts up, it loads config files and then does class path scanning and build kind of its model of the world and everything. But this is when it starts up. So if you think of containers again, that means that this all happens when the container starts up. And that takes a while. And then, so with Quarkus, what we try to do is, instead of doing all that, at runtime, at startup time, we're trying to do all of this, or as much as we can, during build time, before the application actually gets packaged, which means that during runtime, we have a lot less to do, right? So it starts up quite a bit faster. So that's kind of the cool thing about Quarkus. And then, so you can use Quarkus on the JVM, or you can compile it down to native, of course, just like most other frameworks. And but there's some cool things about native compilation with Quarkus as well that we'll get into in just a second. So this is my favorite part about Quarkus. It's not necessarily, yes, it's nice that it starts up fast. It's nice that it has a small memory footprint. But what's really cool about Quarkus is that it has a bunch of different ways of making the experience of working with Java and Quarkus a lot more fun. So one of them is, so of course it's based on standards. So Quarkus uses, your Java EE standards, the Java standards, uses, Vertex and all that good stuff. So if you're used to that, hey, great. You basically already know Quarkus for 99%. What's really cool with Quarkus is that there's this dev mode. This basically, you can start Quarkus on your local machine in dev mode. It's going to start up, and it's going to just keep checking to see if you make changes to in the class path. And so every time you make a change, it's going to automatically reload. When you let's say go into your browser or whatever, you make a new request, it's going to automatically reload your application. So you don't need to recompile, redeploy every time you want to test something. Quarkus does that automatically. So you can just go to your browser, hit refresh, and it's there. So make a code change, refresh, it's there. Which, if you're a developer of a couple, of some other language where that just happens, then that's not so cool. But in Java, that's pretty cool, right? So you got our little guy here that says, wait, so you just save it and your code is running and it's Java? And the guy says, I know, right? Supersonic Java. So that's pretty cool. another cool thing with Quarkus is that has this concept of developer services. So who knows test containers? So basically it uses test containers built into Quarkus. So let's say that I'm developing an application and I'm adding an extension to use a Postgres database or a Kafka topic or something. Actually, as well, of course, you have to have a Docker podman or something running on your local machine, but Quarkus will look and see, hey, you've got this dependency on a database. Do you have something configured on your local machine? Do you have a database running on your local machine? Is that configured in your application properties? If not, no worries. I'm just going to start up a container with that dependency, for example, a Postgres database, and wire that up. So it's going to set the configuration so that it connects to that database automatically. And then you can even go and see what exactly that configuration is and then copy it down. Anyway, so that's the developer services. So Kafka or there's a whole bunch of different developer services that you can use just out of the box, which is pretty nice because otherwise, having to configure a database on your local machine or, Lord forbid, a Kafka instance with all your zookeepers and all that stuff, that's not so easy. You also, so you have live coding. You also have continuous testing. So kind of the same concept. So if you have unit tests, you start your continuous testing. So every time you make a code change, it knows, hey, this class is related to this unit test, so I'm going to rerun this unit test every time I make a change here, or vice versa. If you're making a change in a unit test, it knows, this is what I need to rerun. So it gives you quick and immediate feedback every time as you're developing, which, again, it's pretty handy. It also has a dev UI, so it has a UI in your browser where you can go and look at all these different, developer services that are running, what Quarkus is doing. So again, I was talking at the start about Quarkus doing some optimization, right? So during the compilation time, so in the dev UI, you can actually see what it's doing, how it's optimizing, and what it's going to remove from the class path, because Quarkus does, some introspection to make sure that, hey, this is used, or this actually isn't used by your code, so I'm going to remove all that from the compilation. There's a Quarkus CLI, which, again, it's not super crazy, but so you can either use Quarkus with Gradle or Maven, or you can just use the Quarkus CLI, which means that you can do like Quarkus dev or Quarkus build or whatever. You can even you can say Quarkus image build or image push, and it's going to build your application. So build build your application, build a container, and you can even push it automatically, all from one command, which is kind of handy, right? And then one of the last but not least is unification of imperative and reactive programming. So Quarkus has a lot of reactive programming kind of built in underneath. Now, me, for example, I'm not a super deep expert in reactive programming, but what's nice with Quarkus too is that I can write imperative code, right? So just every statement gets handled one at a time, and it blocks every time. Whereas with reactive, you got these event loops, but you can use both at the same time in the same, even in the same code in the same class. So for those who are familiar with reactive, usually you kind of have to decide, hey, if I'm going to build a reactive application, that means I have to decide before I start writing this code, that this framework that I'm going to use is reactive, and I can't combine the both. But with Quarkus, you can. which is nice. And best of all, it's still Java, right? So you get all these kind of features, and at the end of the day, if you're familiar with Java, this is really not reinventing the wheel at all. So it uses microprofile, Vertex, REST easy, and if you want to add extensions, you can interact directly with Kubernetes. So you can push your code directly to Kubernetes. You can create config maps or secrets directly from Quarkus. You can work really easily with Kafka and OpenShift, of course, Apache Camel, and all that. So in terms of native compilation, I think we've already had a few sessions about that, so I'm not going to go too deep into that, other than, if you can run Quarkus on the JVM, and probably for 70 to 80% of the use cases, that's probably a good way to go. If you really want to have the fastest startup time and the smallest footprint, then you can do a native build of your Quarkus application. With Quarkus, by the way, that's really easy, because if you create a new Quarkus application, it automatically has a native profile built in. So you can decide, as you're doing your compilation, whether you want to do a native build or not. So Red Hat is on the GraalVM advisory board, and then there's the Mandrill project, which is a downstream distribution of GraalVM, specifically for building Java native builds. And that's what Quarkus uses to. For example, if I do a native build and I don't have GraalVM installed on my local machine, Quarkus will again pull down a container. It's really good at pulling down containers to do a native build inside a container on your local machine. So again, then you don't need to have GraalVM installed and configured on your local machine. So it really tries to make your life as easy as possible, and kind of have the benefits of a lot of the things. So if you're thinking of should I do a native build or just run on the JVM, this is kind of an opinionated scoring. But if you want the maximum developer joy, the best and easiest monitoring, peak throughput, and reduced max latency, then you want to run it on the JVM. If for you it's important to have the lowest memory footprint, a small packaging, and a very fast startup time, then native build is probably the way to go. So what do you want to use? What can you use Quarkus for? Virtually anything. So there are Quarkus-based Kubernetes operators. So there's an operator framework where you can create these automatic components in Kubernetes that manage resources in Kubernetes. You can create GitHub Actions with Quarkus. You can create just regular jobs. Yes, you can build traditional Java applications, even monoliths with it. But this is, of course, the sweet spot of Quarkus is cloud native applications, so event-driven applications, reactive systems, microservices, and serverless and functions. So that's about it for my session. So if you want to check out Quarkus more, developers.redhat.com has a ton of resources on Quarkus, on a lot of developer stuff. This dn.dev/Quarkus tutorial is just a kind of a nice lightweight introduction to Quarkus, where you can create an application from scratch and then kind of add some components as you go. You add a database, and then check out the live the dev mode and all that stuff, and so it's a pretty nice thing. And like I said, if you want to keep up to date, you can follow me on Twitter or Mastodon. I try to post interesting stuff, but I don't know if that's really true, but we'll see. All right, and that's it for me. Thank you. Any questions? Yes.
One of the first slides you compared startup time and peak performance, and like the GraalVM native image was only about 50% of peak performance of OpenJDK. So is that really true? Or like I knew that it's lower, like peak performance, but just 50% seems.
I don't remember exactly the numbers on there,
It
but
was the yellow and red. And
yeah. So that so the
warm up, yes.
Yeah.
But the Graal.
Could you please repeat the question?
Yeah, definitely. So the peak throughput time. There was a slide about the three graphs. So yeah, I think with the native compilation, you're not going to have necessarily more throughput than on the JVM, but you do get the startup time. Like the time it takes to get to the maximum throughput is faster when you're native.
I get that, but if I end up at just 50%, that's just not acceptable. Like if it's like 80, 90%, okay, that's fine.
Yeah. We can look at it later. Yeah. Yes.
How easy it will be to migrate a real world production application or let's say from Spring Boot? Because as far as I understand, if you are running with, well, let's say Red Hat friendly technologies like let's say for cache management, how easy it will be to migrate to Quarkus without minimal changes?
Yeah, that's it.
Sorry, if a library is not available, how easy will be to adapt it, like for instance Hasselcast or any other?
Yeah. So the question was, how easy is it to migrate to Quarkus from, for example, Spring Boot? So Quarkus has Spring compatibility extensions, and so that makes it relatively easy because basically for the most part, you won't have to change your code. You just have to add the Spring extensions. Of course, in your POM, you're going to need to make some changes, but it's fairly straightforward. My colleague Eric D'Andrea, he wrote a book on Spring. Let's say Quarkus for Spring developers, and he does the talks too. But if you want, on that developers.redhat.com, you can find there's a section about books, and you can find that book. But it's overall pretty straightforward. So like I said, there are extensions so that you can keep using your Spring annotations. Now, would I recommend you just migrating your application and keeping all your Spring dependencies? Probably not. But it's kind of a nice way to migrate without too much work, and then afterwards maybe migrate further. All right. Any more questions? Yes.
What are the disadvantages for native Quarkus, and why don't you use native Quarkus on everything instead of Quarkus on JVM? It's so faster than on JVM.
So the question, if I understand correctly, right? So the question is, why should you use native compilation?
Between native and on JVM, and on the graph we see native is way faster and smaller footprint. So why don't we always use native over on JVM?
Because on the JVM you have all the kind of capabilities that the JVM brings, right? So in terms of garbage collection, in terms of throughput and everything, JVM is very optimized to do that. When you do a native build, the GraalVM compiler is going to do kind of an opinionated approach of how to do your native build, but then that's also it. It's not going to be able to optimize afterwards like the JVM does. So kind of depends. Yeah. I think we're out of time, but if anybody has any more questions.
You'll be up there.
Yeah.
Okay.
Thank you so much.